Hi guys, hope you all are doing good. So in this today's lecture we are going to learn a very famous problem called Tower of Hanoi. So this is our problem Tower of Hanoi. So this problem is important because it helps us to understand recursion in a simple way. So without any delay, let's begin. Suppose we have three rods. Suppose the first rod is A and second rod is B and third rod is C. So this is rod A, this is rod B, this is rod C. So rod A contains some discs. So discs, suppose the discs be like this. So the discs are arranged from largest at the bottom to the smallest at the top. So for example, disc 3 at the bottom, suppose this is the disc 3. So and this is disc 2 at the middle and disc 1 at the top. So this is the array in the 1, 2, 3. So our goal is simple. We must move all the disk from rod A to rod C. So it's actually easy, but here comes the twist. We need to follow three main rules. We need to follow three main rules. Let me write. So these are the three rules. So the first rule is we can move only one disk at a time. And the second rule is we can move only the top disk of any rod. So and the third rule is larger disk can never be placed on the smaller disk. So these three rules must always be followed. So here comes the tricky part. So we need to follow these rules. If there is no rules, we can simply shift A rod to the C rod without any rules. So in this problem we have rules, no? So we need to follow these rules and we need to proceed. So with these rules it will be some difficult to follow, but it's actually easy. Let me explain. So now let us solve the problem with three disks. So initially we have three disks at the rod A. So rod A is our source rod. So we have 3, 2, 1. So in this rod B, so rod B is empty. So rod B is empty and the rod C also it is empty. So it is empty. So for the step 1, so what is the step 1? So let me write the step 1 here. So the step 1, so we are moving the disk 1 from A to C. So first disk, we are moving A to C. Okay. So the step 2, so this is the first step. So let me erase it. So it will be better, understand, it will be better. So let me write here 1 comma and second step. So we are moving second disk. So second disk, we are moving second disk from A to B. So in the third step, we are moving first disk. We are moving first disk to C to B. So initially the first disk at A. So we are moving A to C. Again we are moving to C to B. So in the fourth step, we are moving third disk. So moving third disk to we are moving to A to C. So on the fifth step, we are moving again first disk. So first disk we are moving to B to A. So this is the 5 steps. So now the sixth step what will be? Can you guess it? So now we are moving the second disk. So we are moving the second disk to B to C. So now the seventh step is we are moving the first disk. So we are moving first disk from A to C. So finally we have successfully shifted the all disk without breaking any rules to the source rod to the destination rod. So finally the Tower of Hanoi will be, so let me draw this. So first, second, third rod. So this is A, this is B, so this is B, this is C. So now the disk will be like this. So the problem is solved. All disks have reached to rod C. So you may notice something interesting. To move the largest disk, we first had to move the smallest disk away. So that's why we have moved the first disk from A to C to move the largest disk. After moving the largest disk, we again move the smallest disk. So this same idea keeps repeating. That's repeating process is called recursion. So let us understand recursion here. Suppose we have n disks. Suppose we have n disks. So to move n disk from source to destination, first we move n minus 1 disk from source to auxiliary. So we are moving n minus 1 disks to, let me write, n minus 1 disks to source to auxiliary. So then we move the largest disk to the destination. Finally, we move n minus 1 disk to, finally we're going to move n minus 1 disk to auxiliary to destination. Auxiliary to destination. So this is all about the Tower of Hanoi problem. So in simple words, move small disk away, move the big disk. So bring all small disk back. So the same process repeats again and again until only one disk remains. When only one disk remains, the solution is very easy. So just move the disk directly to the destination dot. So this is called the base condition. So let us see the important formula for Tower of Hanoi. So the minimum number of moves required is 2n minus 1. So let us see, suppose if there is only one disk, we need 2 power n. So that is, we need only one step. So only one step required when n equal to 1. Suppose n equal to 2. So if n equal to 2 means we are going to n minus 2. So 4 minus 1 equal to 3. So when n equal to 2. So we need 3 steps. Suppose if in this example we have taken 3 disks, no? So n minus n equal to 3. So 2 power 3 minus 1. So that will be 8 minus 1. So we get 7 steps. Let us see we got 7 steps or not. So we have got 7 steps. So this formula actually works. So this formula is for to calculate the number of steps for when there is n disk. So I hope this lecture is clear to everyone. Hope Tower of Hanoi is easy for you after seeing this video. So thanks for watching and see you guys in the next lecture.